In this lecture, we're going to learn about the this pointer. And this is a special pointer that is maintained by C++ to really help you manipulate the current object. And it is the current object for which a given method is being executed. Here is a simple example with our dog class, and we're going to show some usefulness for the this pointer. The first thing we're going to look at is the syntax. For example, here, we might need to print the address in memory where the object was created and do that from the inside of the function. And to do that, we use the this pointer. For example, we can put out a message, and we can do that through a statement like we have here. We are printing dog name constructed at a given memory address, and we use the this keyword to get the address of the current object for which a specific method or function is being called. In this case, it was the constructor of the dog object here. We can also do the same thing for the other constructor, and you see we are using the this pointer. This is one of the uses you have for the this pointer. Again, the this pointer is a special pointer that is maintained by the C++ system, and it is going to be pointing to the current object that is being manipulated by the C++ runtime. And it's going to be manipulated through a special function of the class object that is being called. This is the meaning here. Here is another use case for the this pointer. It may be used to resolve conflicts when you have a parameter and a member variable that are named the same way. For example, here we are calling the setName function. It has a parameter with a name, dog name, and it has a member variable called dog name. So if you do a statement like we have on top here, the compiler is going to be confused. You're going to say dog name equals dog name, and it won't really know which dog name you are referring to. We can resolve this conflict by saying this and say pointer access notation and say dog name. And this thing here is going to be the member variable. And we're going to be assigning to the member variable from the parameter. This is the meaning here. And we can use the this pointer to resolve such conflicts. Another use we have for use pointer is if we want to set up chained calls, for example, using pointers. And we might need to do something like this. So we have a dog pointer set up on top here, and we can do something with our new object. For example, we can call a function called printful on our dog object. After we print the information, we're going to set some information on the dog. And you see we are setting all of the information through one statement. The way we achieve this, our setters are going to be returning a pointer to the current object. And we're going to be grabbing that return value and calling stuff on it directly because it's a pointer, and we are going to be using the pointer access notation. So we're going to call setName. setName is going to return a pointer. We're going to use that pointer to set the breed, and setBreed is going to return a pointer. We're going to use that pointer to set the age. And after this entire line, all the information is going to change about our dog, and we can see that here. And after we do whatever we want with our dog object, we're going to release it from memory. So this is another thing you can achieve using the this pointer. And this is how you can set up these setters. It is nothing complicated. We have setName. It's going to return a dog pointer, and we're going to return this. Okay, and this is going to be a pointer or the memory address of the current object of the dog class. We have the same setup for setDogBreed. We return a dog pointer and we return this. The same setup for setDogAge. We return a dog pointer and we return this. We can do the same thing using references, but our setup is going to be somewhat a little bit different. We have our dog object here, and we're going to do our chained call here. So we're going to say setName through the pointer because we have a dog pointer here, but after that, we're going to return a reference from the functions here. So setName is going to return a reference. We're going to go through that reference to set the breed. setDogBreed is going to return a reference, and we are going to go through that reference to set the dog age. And if we print the information now, we're going to see that we have new information in our dog object. And after we are done with our dog object, we have to remember to release it from memory because it was allocated dynamically from the heap. Here is how you can set this up. It really is nothing complicated. We just have our setters and we are going to return a reference. But before we return through the this pointer, we will need to dereference the this pointer and get to the actual thing that is being pointed to. That's why we have this star operator here. And for the other setters, we're going to do the same thing. We're going to return a reference. We're going to return a dereferenced version of this. We're going to return a dog reference for set dog age. And we're going to return a dereferenced this pointer because this is a reference we are returning here. So this is what the this pointer is about. Now we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is the this pointer. We're going to grab our template files and we're going to put them in place. And then we're going to open this in Visual Studio Code by dragging and dropping here. This is going to open our folder. We're going to open the main CPP file and we're going to close the left sidebar here, so that we have some more space to work with. I am going to put in a version of our dog class. It is pretty limited right now. It just has a destructor and a constructor and a constructor, and we have our member variables. And we're going to tune this a little bit so that we can work with this however we want. The first thing we want to do is to print the addresses of dog objects that we construct and destruct here. And we're going to do that in our constructor. So let's go to our stdc out statement here. And we're going to say at to mean the memory address where the object was constructed. And we're going to say this. So when we do this, this is going to be the address in memory of the current object that is being constructed by our constructor here. And we're going to say the same thing in our destructor. We're going to say at, and we're going to say the memory address where the current object is being destroyed from. So after we do this, if we go in the main function and, for example, set up a dog object, we're going to say dog, we're going to say dog1, and we're going to give it the information. We're going to give it the name, which is going to be Fluffy. We're going to give it the breed, which is going to be a Shepherd. And we're going to give it the age of 2, like we have been doing all along. When we do something like this, this is going to call the constructor because we are trying to set up an object. And before the main function ends, we're going to call the destructor. And we're going to see things happening here. Let's say done so that we know that the code is actually running. We're going to say stdc out done here. Okay, we have the setup done. We can build and run the application. We're going to use GCC to build, and the build is good. We can bring up a terminal to try and run the application. And now, if we run Rooster, we're going to see that dog constructor called for Fluffy at this memory location. And the current object is this object here, which is being constructed. And we're going to have access to its memory through the this pointer. Hopefully you can see how powerful this is. If we didn't have the this pointer, the only way to get the address to this object would be to grab the address from the main function or from wherever we are setting up our object here. But we have access to this address from the inside of the functions for the class. And this is really cool. So we can manipulate these addresses if we need to. And we're going to show you another use for this. So suppose we need to set up setters for our class here. So we need a setter to set the name, the breed, and to set the age here. So let's set up our setters. We're going to say setters, and we're going to say void set name, or let's be explicit, set dog name. That's going to be better. And we're going to pass a string view. We're going to say std string view, and we're going to say name param. And we're going to put the bodies in our class here. But I would encourage you to be consistent if you are doing this in real code. We are learning here and we are taking some shortcuts so that we can do things simply. But what we want to see now is what happens if we have a parameter named the same as a member variable. So how do you set this name to the member variable called name? So if you have a case like this, you're really going to be in trouble. Because if you say name equals name, let's try this. we should get a compiler error or a squiggly line because the compiler is not going to know which name are you using here. Is it the member variable? Is it the parameter? It's not going to know. And let's try to build and see what we get. We're going to use the GCC. And surprisingly, GCC is taking this. And it's probably knowing that we have a member variable named name, and it's going to assign the parameter to that member variable. So behind the scenes, GCC is going to change this to this. It's going to use this name equals name. This is the syntax we want, which is really not confusing. But what we have on top here is going to be confusing, and some compilers are not even going to take this. Let's leave this in and actually build again with this. I want to see that this actually works. So we're going to build successfully, and if we go down in main and try to say dog1 set dog name, let's say Pumbaa. Let's see what happens if we do something like this. We're going to try and build again, and GCC is going to take this, and this is really cool. So let's put in a function which is going to print information about our dog. We can do that down here, and it's going to return nothing. It's going to be called print info, and it's going to basically print the name, the breed, and the age. So it's going to say stdc out. We're going to say the address where the dog object lives. I think that's more meaningful. We're going to say this, and then we're going to put a parenthesis and say the name. I think we can put an angle bracket here and say name, and we're going to say the dog name. We can go down and say the age or the breed and say the age. And we're going to dereference the age member variable because it's a pointer. We're going to say dereference page here, and I think this is going to be it. Now we can put a new line character, stdendl. And if we go down now and say printful, before we set the name, we're going to say dog1 printful. We're going to print the information about this dog. And after we set the dog name, we're going to go down and also say dog1 printful. You can play with these things, and I really encourage you to do so. So we're going to build this. We're going to use GCC. So the build is good. We can clear and run rooster. This is going to say the constructor was called for Fluffy at a given address. We're going to say the dog. We're going to print the information, and we're going to say it's a dog object at this address. The name is Fluffy, and we're going to print the dog for the second time. You're going to see that the name is still Fluffy, and we have a problem here. Why is that? Why is our object not being modified? Let's go up and see our set dog name function here. So we're going to remove this, and we're going to use the this pointer, and we're going to build again, and let's clear now and run rooster. And now you see that the changes are actually making sense. So what is happening with the assignment here, the compiler is assigning the value of the variable to the variable itself. And this is really doing nothing, and it is not what you expect. I was fooled a little bit by the compiler because this was compiling, but it's not going to do what you want. When you call set dog name, you probably want to take this name and assign that to the member variable name of this class. But this is not what it's going to do. Let's build again and really show you this. So it is a really good advice to practice and really try things out yourself. We're going to run rooster. You're going to see that after we set the dog name here to Pumbaa, and we try to print the information is not going to be n. The name is not going to be Pumbaa for the second call here. And what this is really doing is doing nothing here. This does nothing. And you really need to know this. If you want to affect your member variable, you will have to go through the this pointer. And this is going to tell, take the name member variable of the current object and assign the value in name, the name parameter to that. And that's going to set your name to whatever new name you passed when you called the set dog name function here. So hopefully you really understand this. Now if we build, we're going to see that the Pumbaa name has been applied. Let's build again. So we're going to clear and run rooster. And we're going to see now that the name is Pumbaa. And there is some annoying thing we have in our constructors. We don't have a space before at here. And it is really annoying to look at here. So let's build again and fix this. We are going to use GCC. The build is good. We can clear and run rooster. And now we have what we want. So this is the second use case you might have for this pointer through setters that use the parameter that is named the same as your member variables. So we're going to set up all the other setters. We're going to set up a setter for the breed. We're going to say std strength view, and it's going to be breed. We can do that because now we have tools to really do this properly. We're going to say this breed, and we're going to say equals breed. This is going to do, and we can set the age, and we're going to say void set age, dog age, and we're going to pass in a value, and we're going to go inside. What is it called? It's called pH. I don't think it makes sense to call the parameter pH because it's not a pointer. So we're going to go inside and just dereference our pointer. So we're going to dereference that, and we're going to say this. So we're going to go inside and say this pH equals age. I think this is going to work. And we need to dereference this pointer because what we have as a member variable is the pointer. So we need to go through the ugly syntax you see here. And this is going to set our age. So we can go through this and really change the information. So we're going to change the breed here. Set dog breed. Let's go down and choose that. And we're going to say wire fox terrier. And we're going to go down and set the age. We're going to say dog 1. Set dog age. And we're going to say 4. Why not? So we changed the information of our dog through our setters here, and we're going to print new information. Let's build again. We're going to use GCC for that. The build is good. We can clear and run rooster. This is going to give us new information for the second print here. So name is going to be Pumbaa, breed is going to be wire fox terrier, and age is going to be 4. And we have the information for our dog object here. Okay, now we have this, and we want to see how we can set up chained calls using the this pointer. And in this case, we will be using pointers. Let's change our setters to return dog pointers. We can do that. And we're going to go down to set dog breed. We're going to return a dog pointer. And we're going to go to set dog age, and we're going to return a dog pointer. Now, after we do this, we will need to return these pointers, and we're going to go inside and say return this. Remember, this contains the memory of the current object, so we can return this and feed that to a returned pointer. So we can go down in all the other functions and really say this. We're going to say return this. We return the memory address of the current object. Through the setters that we are doing here, we're going to return this. And after we do this, we can change the setting we are doing here to be one statement. And we can comment this out. I think we can do that. And what we're going to say is dog1, and we're going to say set dog name, and we're going to pass in Pumbaa, but this is going to return a pointer now. Set dog name is returning a pointer to the current object, and you can see that here. This is what we are returning. So we can go through this pointer and call some other functions. For example, we can say set dog breed directly, and Visual Studio Code is going to figure out that what we are returning is a pointer, and it's going to change our access notation here to a pointer access notation. And we're going to use this in one single statement. So we're going to put in our breed, and we're going to call the function to set the age. Okay, you see that it uses pointer access notation, and this is really cool. So we're going to put in our 4, and you're going to see that this actually works, and this is really cool. If you don't want to do things in 3 steps, you can give your users the option to do things in 1 step using returned pointers like this. And this is really cool. I use this all the time for my classes that I design in my applications. So if we build, we're going to see that the build is good, and we're going to clear and run rooster. We're going to see that the information is n, name is Pumbaa, breed is wire fox terrier, and the age is 4. And we were able to do all these changes in one go. So we can even change this to use references. Here we are using pointers. So let's say that we are using pointers, but we can also use references. Let's go on top here and say that this is using pointers, and we're going to comment this out. But before we do, we're going to copy all this because we're going to need that. And we're going to comment all this out, and we're going to go down and say change calls using references. And we're going to go down and put in our code, and we're going to change our setters to return references instead of pointers. We can do that. So we're going to change the star here to an ampersand symbol here, and this is going to do the magic. So we have a dog reference returned from all these functions. So because we are no longer returning a pointer, returning this directly is going to give us a compiler error. We need to dereference this pointer and get to what is pointed to. Now the compiler will know that we are returning a reference to the current object. And this is the syntax we can use to do this. Let's go down and dereference or the returned pointers. And if we go down, we're going to see that this is good already. And we can go down and set up our chained call using references. And we're going to go down and say dog1. We're going to set dog name, and we're going to pass in Pumbaa, what we have been doing all along. Now we're going to use the .access notation because what we are returning is a reference. And you're going to see that Visual Studio Code is going to pick this up. The breed is going to be Wirefox, and we're going to say set dog age, and we're going to pass in our for, and you're going to see that this is valid C++ syntax. And if we print the information, we're going to have new information applied to our dog object here. We can build and see that this is actually working. You see the build is good. We can clear and run rooster, and we're going to see that information has been applied to our dog object. So these are a few examples showing some of the usefulness for the this pointer. We have seen that we can use the this pointer to print the memory address of the current object. If we go down and look at our constructor and the destructor, we are printing the address of the current object in our debug statement here, and this is really cool. We can use the this pointer to resolve conflicts in our setters. For example, we can use a parameter that has the same name as the member variable, and it's not going to be really confusing and lead to bad results. It's going to change the actual member variable and change it to whatever you passed as the parameter. And this is really cool. We can also use the this pointer to set up chained calls for our function. And we have seen that we can do that either through returning pointers like we are doing here and using the this pointer as a return object for our function here, or we can use returned pointers to do this. And if we do that, we're going to be able to call our functions in one go like we are doing here using pointers, or do the same thing using references like we are doing here. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to learn about struct. Go ahead and finish up here and meet me there.